In part 1, we are asked for each of the following tables, describe how to find the next term in the sequence, write a recursive rule for the function, describe how the features identified in the recursive rule can be used to write an explicit rule for the function, write an explicit rule for the function, and identify if the function is arithmetic, geometric, or neither. So I'm going to do one with you, the example that we have right here, and then I'm going to have you go through and just do some work on your own to practice all the things that we've learned so far in Module 1. So the first thing we want to do is let's take a look at the table to decide how are we getting from one term to the next. And so if I look to get from 5 to 8, I can think of it as adding 3, and I'm going to see if that consistently works throughout my table. 8 plus 3 is 11. 11 plus 3 is 14. So it looks like we are adding 3 to each term. So for question 1, how to find the next term, I'm going to say that we are adding 3 to the previous term. So add 3 to the previous term. Then question 2 says to write a recursive rule for the function. So if we're adding 3 each time, a recursive rule would say, and you can use anything you want for y, you could use f of x, you could use g of x, you can use h of n, whatever letters you want. I'm just going to use f of x here. So I could say that f of x equals f of x minus 1, remember that's that previous term, plus 3. And then I also have to list my first term, that f of 0 is equal to 5. Next, I want to find the nth term. So how would I go and find the nth term? And so that's getting us ready for that explicit rule. So to find the nth term, I'm going to start with the 5, since that's my first term. So I'm going to start with 5, and I'm going to add 3 n times. Oops. And I know that because, again, as we were doing before, if we compare the number of times we are adding 3 to the x's that we have, or we can think about this time we're starting with 0, so we don't have any 3's here. Then we're going to add 1 3 here, 2 3's here, and it's lining up with our x's, or in this case, if we're finding the nth term, with our n's. So then we can use that to help us write our explicit rule. So our explicit rule, if we want to do it in terms of n, we could say that f of n equals, and then we're going to follow the directions that we have right here. We're going to start with 5, and we're going to add 3 n times. And then finally, number 5 says, is this an arithmetic, geometric, or neither? And since we are consistently adding something each time, that would give us something that is arithmetic. Now I would like you to do the next ones, so A through G, and see what you can do, and then go to the video to check your answers.